Hello everyone, today we'll be talking about sums of infinite geometric series. And so in this first video, we're going to be looking at partial sums. And so a partial sum is the sum Sn of the first n terms of an infinite series. So we have a series, it goes on for an infinite amount of terms. A partial sum is we're just going to take the first, say, n terms. So let's say we're taking, for instance, S7. That means we're just summing the first 7 terms of this infinite sequence. And something that we can see is that the partial sum of an infinite geometric series approaches a limiting value. So for these two examples, we're going to consider the infinite geometric series, find and graph the partial sums Sn for n equals 1, 2, 3, 4, and 5. Then describe what happens to Sn as n increases. Okay, so let's first look at number 1, I have 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, and that goes on forever. So first it asks me to find the partial sums for S1 through S5. Well, S1, that means I'm just summing the first term, and the first term is just 1/2. S2 asks me to sum the first two terms, so I do 1/2 plus 1/4. And when I do that, that gets me 0.75. And we're going to go ahead and write these all as decimals. S3, that means I am summing the first 3 terms. And so that's going to be 1/2 plus 1/4 plus 1/8. And when you enter that into your calculator, you're going to get approximately 0.88. S4 is saying I'm summing the first 4 terms, so it's going to be 1/2 plus 1/4 plus 1/8 plus 1/16. And when you enter that into your calculator, you should get approximately 0.94. And then S5, I'm adding the first 5 terms. And that will get you approximately 0.97. And so for this, you can just graph this on Desmos. So to do that, you enter in a table. For your x terms, that's just going to be 1, 2, 3, 4, and 5. And then your y terms are what those sum values are. So the first one we found would be 0.5. Next one is 0.75. 0.88, 0.94, and 0.97. And so I see that my graph looks something like that. And this last part asks me to describe what happens to Sn as n increases. And so I see as my n increases from 1 to 5, that my S value, my Sn, is getting closer and closer to 1. And so I can say from the graph, Sn appears to approach 1 as n increases. And we can see that from our points here too. 0.5, this last one ends up being 0.97, and I see it's getting closer and closer to 1. Okay, let's try another example. So first I want to find the partial sums. So S1 is going to equal to 2/5, which if you enter that into your calculator, and I'll go ahead and for this example show that, that is going to equal 0.4. S2, I'm adding the first 2 terms, so I have 2/5 plus 4/25. And when I enter that in, I get 0.56. S3 is equal to the first 3 terms summed. And so when I add 8/125, I get approximately 1 point, oh, that's not right. I get 0.64. S4, I'm going to add the first 4 terms. So when I add 16 divided by 1625, I get approximately 0.63. And then S5, I'm going to add the first 5 terms. So now I need to add 32 over 3125, and I get 0.64. And so I see my graph looks something like this up here, and looking to see what it's approaching, I see it's getting closer and closer to 0.65. I notice that with these last 3, they're all very close together, and I see it's just getting closer and closer to that 0.65. So I can say from the graph SN appears to approach 0.65 as n increases.